Okay, hello everyone, I'm Yap Ifan, and today I'm gonna present on how solar panel works and also the quantum physics behind solar panel. Now when you hear the word quantum physics, you might think that it's a crazy word that you won't ever be able to understand. But actually all those crazy quantum theories that you've seen can be understood a little better and easier with the basics of quantum physics that I will explain later. So this is the list of contents that we'll go through today. So renewable energy, we know that it is essential for a sustainable future because it helps reduce the greenhouse gas emissions and reduce the dependence on fossil fuels, which is predicted to run out in this century by scientists. And it also promotes the environmental conservation. So today we'll explore one of the best renewable energy and how does it work. So why solar energy? The biggest reason why solar energy is the best renewable energy to invest in is because that sun always provides high amounts of energy at any moment. It is also one of the least environmentally destructive, most economical and versatile in placement. Meaning that, for example, you look at other renewable energy, you have wind and water, they take up a lot of space. But solar energy, it doesn't take as much space, you can just install them on your roof. So it is a very good source of renewable energy. Another fun fact is the sun actually provides more energy in an hour than the energy the world uses in a year, which is just crazy. You can see here the sun provides 173,000 terawatts per hour compared to the energy the world uses in a year, which is roughly around 170,000 terawatts. So it will be a waste if we don't capitalize this energy properly. So how does it work? To understand how solar panel works, we need to first understand how electricity is generated. We know that current is a positive charge flowing in a circuit. That means there should be another opposite charge flowing in another direction, which is the negative charge. Meaning, as long as there's electrons flowing in a circuit, there is current in the other direction. So that is how electricity can be generated. We need the flow of electrons. And when you look at lights, this is where the quantum physics comes in. When you look at lights, I'll ask you a question. Do you think that light are waves or particles? Now, you might say that it's a wave, it can't be a particle because particle has to be a body of a mass. But quantum physics argues the opposite. It is not a particle as well, it is not a wave. It is both at the same time. Now when I say that, it can be a little bit hard to imagine in your minds, like, what do you mean both at the same time? Why is it hard to imagine? It's because we actually can't really see it in real life, but okay. When I tell my friends about this wave and particle duality in light, they think that it's a particle moving in this way. So they think this is how light works, but that's actually not true. This is not true. Not true. How photons, basically light particles, actually look like is something like this. Now it's not exactly a particle, it's just like an imaginary packet of energy, and the energy is carried in the form of a wave. This is called a photon. And this wave-particle duality is what makes up all those quantum theories, which I'll elaborate more later. Also, since photons they share wave properties, that means they carry energy as well. we call them quantum energy. So when this photon, it emits from the sun towards the solar panel, when it hits the solar panel, the energy, the quantum energy in the photon gets transferred to the electrons here. The electrons of the material of the solar panel, which is usually silicon, and it transforms from quantum energy into kinetic energy of the electrons. Now, when the electrons get kinetic energy, that means they are, vibrating a lot harder to a point where the nucleus eventually can't hold the electrons anymore, so they will escape the orbit and they will be free to move around the circuit, which generates current in the opposite direction. So that is just basically how solar panel is, how it works basically. It's just that the energy from here gets transferred to the electron, it moves, which then generates electricity. And then you might think to yourself, so we can just, put a solar panel and then run a light on it, and then it can generate electricity forever. That doesn't work, because we look at here, light is a spectrum, and in order for it to give the electrons enough energy to escape the nucleus orbital, they need to have high wave frequency. Now, why is that? Actually, is that dust? Oh, we'll see why now. So we know that previously we have learned before the equation for a wave, which is the velocity of the wave is equals to the frequency times the wavelength. And in order to calculate the energy for quantum, this is the formula for quantum energy. This is the frequency of the wave. This is a constant, which is Planck's constant. And let's come back here. This is the wave. Since we're talking about light waves, this should be changed into the speed of light, which is c, and then its frequency and wavelength. You can see from there. Usually, the light that works on solar panel is around the end of the visible spectrum to UV. Actually, it starts from UV, I think, around here. I've read it's around 400 times, and I don't remember, but UV is the only light that works on solar panel, so that's why we can't just shine like random lights on solar panel to generate infinite electricity. Now, just now we talked about this energy formula. What if we don't have the information of the frequency of the light wave? We can also change the formula a little bit into hc over lambda. We need to know the wavelength here without knowing the frequency, because we can change this formula a little bit, making f the subject, and we substitute back in here. So we have two different equations for energy. So basically, that means that not all the light works on solar panels. In conclusion, physics plays a big role in how energy is generated in solar panels. So learning more about quantum physics allows us to explore energy and innovate in electrical and energy industry. Before I end this presentation, I would also like to give you guys a bit of thing to, maybe you can research about it. It's the one I talked about at the start about how all those crazy quantum theories come from. You know that photon is both a wave and a particle at the same time, and it's not just photon who shares this property. Electrons also have the same wave-particle duality, and that is why we have those multiverse theories, because even though it is both a particle and a wave at the same time, we can't observe them both at one time. What I mean is, you can conduct an experiment to see if electrons have the property of a wave. That will come out as true, and then you test if it is a property of a particle, and that will also be true. But you just can't test if it's the same at the same time. There's also another experiment which shows a crazier thing about electrons, which is the double slit experiment. It shows the superposition of electrons. So basically what they did is they emit a single electron into this double slit, and what happens is that if we don't observe it, if we don't look at it, we don't just observe it, it is known that electrons will appear at both slits. One single electron will appear at both slits at the same time, which is just crazy. But if we observe it, it becomes randomized. The electrons will either be only here or here. So what does this mean? This means that there are infinite possibilities. It's just that when we observe, only one of the random possibility happens. So this is where all the multiverse stuff comes from. You can go research more about that. It's a very interesting topic. Personally, I feel like, because I also did research about this on my own. It's not in my syllabus, because I like quantum physics. And that's basically it. Thank you.